For a lot of us, a standard gigabit Ethernet connection, or even a lot of times just whatever we can get from Wi Fi, is more than enough to fulfill our daily internet tasks like searching for dope song lyrics or watching videos online. But what if I told you that you could have it all and more by upping your network speed? Well, you can't really have it all since no amount of magic sauce can increase the speed given to you by your ISP, but you can have insanely fast network internally using something like this gal right here. Ain't she a beaut?
You smell that? It smells like a bit goblin.
So what I have right here is the Mellanox. Oh, well. So what I have right here is the Mellanox CX311A 10 gigabit Sfp Plus network card. What's special about this card and others like it is that it allows you to connect your device to the rest of your network with 10 gigabit of bandwidth. That's 10x your standard 1 gigabit connection. You just got to take the card and plug it into an open slot in your motherboard and, well, wait a minute. The cunning among you may have noticed by now that this is not your typical RJ45 connector there that you'd connect an Ethernet cable with. So how do you plug a cable in? Great question. This right here is what's called an Sfp Plus connector, which is an improved version of the original SFP or small form factor pluggable connector, which that was designed to be a compact, hot pluggable, and modular network interface. A standard Ethernet cable will match the hot pluggable and compact bits, but the modularity of SFP allows it to use a DAC or direct attached copper cable, just like this one right here with these modules at the end, which are great for high-speed short distance runs. Or you can get transceivers that convert it to other interfaces like fiber if you need really long runs for whatever reason. Or there are even transceivers to connect with Ethernet cables using RJ45 connectors if that's what you really need. You should also know that SFP and Sfp Plus are pretty much the same connector as far as I'm aware, with the main difference being that SFP is only rated for speeds up to 4 gigabit depending on the type of connector, and in terms of networks are only really used for connections up to 1 or 2.5 gigabit, whereas SFP Plus is rated for up to 16 gigabit speeds, again depending on the type of connector, and for networks they're used for 10 gigabit connections. It's also important to note that even if they are physically similar, the ports are not really interchangeable since SFP Plus modules cannot auto-negotiate down for SFP ports, and although in some cases SFP modules can be used in SFP Plus ports, there's no sense in buying an SFP Plus card or switch if you're just going to put an SFP module in it, since you'll be getting 1 gigabit connection when you spend the money for 10 gigabit. I'm sure it's worthwhile if it's really just all you have on hand and just need something working right this instant, but I really wouldn't recommend it if you're buying new equipment. So the reason you'd want to spring for something like this, instead of a NIC with a 10 gigabit RJ45 connection, is that while 10 gigabit Ethernet devices are coming down in price, you can still find these used SFP Plus cards and DAC cables to go with them for significantly cheaper. This is because usually hardware like this is used in enterprise server deployments, and as they upgrade to newer and faster devices, this stuff gets accessed like this and shoved out the door for whatever little they can get for it. For instance, a typical 10 gigabit Ethernet card will run you about $100 or so, like this one from ASUS. A 2-pack of 1 meter Cat6a cables is about $7.50, since I couldn't find a single pack, and a switch with just a couple 10 gigabit RJ45 ports, like this 8-port one from Netgear, is about $200. Whereas this Connect X3 card from Mellanox cost me $45, and I frequently see them as low as $30 on eBay. 2 1-meter DAC cables for about $20 or $10 a piece to match the pair above, and a similarly spec'd MikroTik CSS610 8-port gigabit switch that has 2 10 gigabit SFP Plus ports for $104. Though on that point, I would see if there was a MikroTik CRS610 switch, since Router OS is much better than Switch OS, but that's another story for another time. But getting back to the matter at hand, a similar setup with the SFP Plus connectors saves you a whopping $137.50, or close to $200 if you wanted to get 2 of these adapters that you can utilize both 10 gigabit ports on the switches. Though while we're talking about pricing, I would like to note that you can also get transceivers for the SFP Plus ports to convert them to either a standard Ethernet connection or even fiber, but those transceivers do have a substantial cost on them per connection, running around $20 or so for even the cheaper ones, to much more depending on what you need. Moving on, let's take a look at how to set one of these up. Just like any other PCI Express card, you just gotta plug this into an open slot on your motherboard, and there's nothing really special there. And once it's in, you just need to plug an Sfp Plus cable with one end in the new card and the other into a switch or another PC with an Sfp Plus port. Now I'm here in Windows 10, and you can see that we don't have a network connection since Steam cannot connect. Let's just close that. To configure the network, just click on the network icon in your system tray, then Network and Internet Settings, then under Advanced Settings, click on Change Adapter Options. This window will pop up, and you might have a couple network interfaces here. You can tell which one is the one you want by reading the descriptions, where the first one here for me is a Realtek NIC, which is the built-in Gigabit interface on my motherboard, and the second one says Mellanox Connect X3, which is my 10 gigabit card. Right-click on the correct adapter, go to Properties, then in the new pop-up window, select Internet Protocol version 4, and click on Properties. In the new window, select the second option to manually configure IP address settings, and now we just need to assign an IP address on a different subnet from the one your primary interface is on. Here I'm going to go with 10.7.5.50 and give it a net mask of 255.255.255.0. We don't need to assign a gateway or DNS servers since this won't be going out anywhere, so you can start clicking OK to get out of the menus. You will need to repeat this process again for your other system, be it another Windows machine, a Linux server, or a NAS like TrueNAS or Unraid, using the same subnet and a different IP address. Now to test this, I'm in a Windows 10 command prompt, and I'm going to do a simple file transfer from a virtual machine with storage on a ZFS mirrored SSD array on my NAS to the local SSD on my test bench. I'm using the SCP tool, which does a copy over SSH. You can set up a regular Windows file share on the remote system. SSH is just already available and it'll show the same results, so I figured, why bother? Now I just run this command that pulls the file from my server to my machine, and I'm getting around 220 megabytes per second. Wait, what? That's too slow. We should be seeing like 700, 800, or even 900 megabytes per second. While that may seem a bit underwhelming, since we should be seeing speeds a lot faster, it is a lot faster than 1 gigabit, which would be maxing out around somewhere like 110 to 115 megabytes per second. One reason this could be slower than expected is that the 10 gigabit connection on this virtual machine's host is currently being utilized for storage for several VMs, which eats up a significant portion of bandwidth even when they're sitting idle. And another reason could be the storage speed. And if we actually open up Task Manager and go to the Performance tab, we can see that our network speed is hovering around 1.8 to 1.2 gigabits per second, but our disk usage is maxed out. Woof. Unfortunately, that's a limitation with the local disk on my system, and I really wish I had a spare NVMe SSD and systems really to show this off properly, as in the past I have been able to reach close to 750 megabytes per second on a single VM on my mirrored SSD pool when nothing else was running. But this right here is still pretty good. You'll just need to account for the speed of your storage when you're buying something like this, especially since a mere hard drive will barely even max out a 1 gigabit connection, let alone 10 gigabit. Now let's talk about why would anyone need this. I mean, we rarely, if ever, saturate a 1 gigabit link when surfing the web, and we really only do so when performing a large file transfer like downloading movies, TV shows, or Linux ISOs. So what does it matter? Well, like I mentioned earlier, this will not affect your external network speeds since this only affects the link going to your computer from a switch or another device. But what this is useful for, however, is speeding up internal connections to, say, a NAS, where you store all of your files, or to a backup server so you're not waiting a day for them to finish before the next daily begins, or other similar tasks. It sounds silly and like we're being super impatient, but that's kind of what being an enthusiast is about. Pushing the limits for a nicer experience, even if it's not exactly necessary. Also, if you're editing video off a NAS, especially 4K video, you practically need 10 gigabits so you can have any hope of having a smooth playback experience. Myself, for example, I don't have a 10 gigabit connection to my NAS or servers from my desktop, but that's mainly because of the way my house is built, and I don't really have a better way of connecting to my NAS other than Mocha adapters, which is a story for another time. But what I do use it for is a storage backplane for my virtual machine servers in my home lab to my NAS, which has an array of SSDs mirrored for fast virtual disk storage. On a standard gigabit connection, I wouldn't be able to fully take advantage of the SSD speed, but with a 10 gigabit connection, I can, and I can see write speeds around 500 to 650 megabytes per second and reads around 750, sometimes even 800 plus. That makes it super snappy even with several virtual machines running off of the same pool. It's also really nice having these faster connections for things like transcoding video clips before being imported into DaVinci Resolve, and for the media storage for my Jellyfin media server so it can transcode footage before sending it to a client. It speeds up those processes a lot by making sure the storage speed is not the bottleneck for those transactions. Anyways, that's all I have to say for this one. I really like playing with this networking and more enterprisey hardware since it's more than just what's the best performance I can get for gaming, as there are tons of possibilities that can be done with this stuff. You can use this in a home lab to host your own services and take control of your data, or you can just experiment with it and learn how it all works, so you can be more ready to deploy solutions with this in mind at your job, or even help you land a job because you know what you're doing. I can personally vouch that that knowledge does come in handy. As always, I hope you liked the video, and if you did, then hit the like button and get subscribed and all that junk, or if you didn't, then you know what to do. Let me know your thoughts on this video or ideas for other networking equipment I should check out in the comment section below. I've also got a Discord server for the BitGoblin community. It's slowly growing, and I'm usually available to help anyone out that needs it, or if you just want to chat, I'm game for that too. I hope you all have a great day, and I will catch you in the next one.